Hello friends. So in the previous video we have seen some different types of continuity problems. Okay, now I'm going to take this is the last class of that continuity concept. Okay, now whatever the questions I'm going to solve it here, these are 4 marks very important questions. Okay, so for this there is no different any other concepts I'm going to use it. What we have solved previously, the examples, same method I'm going to apply for that. Okay, so let us take the first question, that is f of x is equals to k cos x divided by pi minus 2x if x is not equals to pi by 2 and f of x is 3 if x is equals to pi by 2 if x is equals to pi by 2. So question is what? This function is continuous. This function is continuous and is continuous at x is equals to pi by 2. Is x is equals to pi by 2, then find the value of k. See, in this function there is a constant k. Okay, then you have to find out the value of that k. Okay, so here condition is what? They have given a function which is continuous at x is equals to pi by 2. Then using that condition you have to find out the value of this constant k. Okay, so after seeing the function, you should know which definition we have to use it. See, in this problem, you are not going to check the continuity of this problem. Already it is continuous. Okay, just by taking the definition, we have to solve it. Okay, so if you see this function, in this we don't have less than and greater than. So therefore, I can't use the second definition of continuity. I have to use the first definition of continuity. Okay, so therefore what I should write? Given function is continuous at x is equals to pi by 2. Okay, so given function is continuous at pi by 2. So therefore, as per the first definition, when we call the function is continuous using the first definition, if limit x tends to c, f of x is equals to f of c. If that both the parts are equal, then function is continuous. Now already this function is continuous, so you have to just note down that definition. So what is the definition? Limit x tends to c, but what is c here? Pi by 2 f of x, which is equals to f of pi by 2, because c value is pi by 2 here. Okay, limit x tends to pi by 2 f of x. So I told you when I solved this type of examples, in the function, wherever not equals to sign is there, that function we have to use it for limit for left hand side. Okay, so what is f of x here? That is k cos x divided by pi minus 2x, which is equals to f of pi by 2. Means what? Equals to pi by 2. So for equals to pi by 2, what is the function? 3. So therefore f of pi by 2 value is what? 3 here. Okay, next part now we have to substitute the limit into the function. Okay, if I substitute the limit as x tends to pi by 2 here, what will happen? Suppose if I put pi by 2 here, cos 90 is 0. And suppose if I put pi by 2 here, 2 get cancelled, left with pi. So pi minus pi will be again 0. Means you will get which form? 0 by 0 form. And this 0 by 0 form is called as what? Indeterminate form, where the function is not defined. Where the function is not defined. If the function is not defined, then how you will find the value of k? It is not possible. So therefore, for this limit the function is not defined. So therefore what we have to do here? We have to change the limit. we have to change the limit. How you are going to change? See here. So where h is equals to pi by 2 minus x, when h is tending towards 0, when h is tending towards 0. So what I have taken here? I have taken one new limit now, that is h as what h tends to 0. So how we have taken that? H is equals to pi by 2 minus x. So this x I have transferred here, it is minus x. So h is equals to pi by 2 minus x. This is possible when h is tending towards 0. Because you know, if h is tending towards 0, means if I put h is 0 here, again minus x you can transfer. You will get what? X is equals to pi by 2. Again you get the same limit. Okay? Or this implies minus x transfer here, it becomes plus x, which is equals to pi by 2 plus h transfer to that side minus h. Okay, so x is equals to pi by 2 minus h. Now this x value you have to put it in the function wherever x is there. Okay, and your new limit is what now? H is tending towards 0. Okay, so let us take now, change the limit, that is limit h is tending towards 0. Okay, k cos x, but x is what? Pi by 2 minus h divided by pi minus 2 into x. X is what again? Pi by 2 minus h, which is equals to 3. Which is equals to 3. Okay. Now here limit h tends to 0. Okay. This is k. This is allied angle property, cos of 90 minus theta. Cos of 90 minus theta. But in the place of theta I am having h here. So cos of 90 minus h is sin h divided by pi minus 2 multiply inside the bracket. So when I multiply 2 inside the bracket, this to get cancelled, left with pi minus into minus plus 2 into h 2h, which is equals to 3. Okay, now plus pi minus pi get cancelled, limit h tends to 0. This is k sin h divided by this 2h as it is, which is equals to 3. Now with respect to this limit h, this k upon 2 is constant. Take it outside the limit, that is k upon 2 is outside. Limit h tends to 0, sin h upon h is equals to 3. Is equals to 3. Okay. Now here k by 2 as it is into, what is the value of this limit? That is limit h tends to 0, sin h upon h value is what? See, in the first year we have learnt with one theorem. Okay, I think it was for 5 marks. That is limit theta tends to 0, sin theta upon theta value is what? 1. So therefore limit h tends to 0, sin h upon h value is what? 1, which is equals to 3. Okay. Now you want the value of k. 2 is division. If I transfer it, it will multiply. So 2 3s are 6. So therefore k is equals to 6 here. K is equals to 6. Okay. So this is 4 marks, very important question. Not only with this, I think total 6 questions are there which are important for 4 marks. Out of that we will get it 1. Okay. So one type I have solved. This was a little bit different compared to those remaining 5 questions. Okay. Now next, so I hope that you understood this example. Okay. So next example I am going to solve it. In that example also it is same, that they will give the function and that is continuous at one particular point. Then you have to find out the value of k. You have to find out the value of k. Okay. So let us take that next question. That is f of x is equals to kx plus 1 if x is less than or equal to pi, and cos x if x is greater than pi, and x is equals to pi. Okay, so next function is what? F of x is equals to kx plus 1 if x is less than or equals to pi, cos x if x is greater than pi, and is continuous at x is equals to pi. This function is continuous at x is equals to pi. Then you have to find out the value of k. If you observe the function, in this I am having less than and greater than. Therefore, you have to use which definition now? Second definition. That is, given function is continuous at x is equals to pi. Given function is continuous at x is equals to pi. So therefore, what is the second definition says? LHL is equals to RHL is equals to f of c is equals to f of c. But if c is what now? Pi. Okay. Now I will say LHL is equals to RHL is equals to f of pi. Okay. Now what we have to do is just find all the three values first. Okay. So first we will find f of pi. So f of pi meaning is what? Equals to pi. Equals to pi. So for equals to pi, function is what? Kx plus 1. But what is x here? Pi. So that is pi k plus 1. Means I just in the place of x I have substituted pi. So pi into k, that is pi k plus 1. Okay. Next you have to find LHL. You have to find LHL. What is the definition? Limit x tends to c minus f of x, which is equals to limit x tends to pi minus f of x. LHL means what? Less than. So for less than pi, function is kx plus 1, which is equals to, now substitute the limit as x tends to pi here. So it is pi k plus 1. Okay. Next we will find RHL, that is limit x tends to c plus f of x is equals to limit x tends to pi plus. RHL means greater than. For greater than pi, function is cos x, which is equals to, now substitute the limit as x tends to pi. If you substitute pi, you get cos pi, and cos pi value is minus 1. Okay, so keep in mind cos function, if it is odd multiple of pi, means what? Cos pi, cos 3 pi, cos 5 pi, cos 7 pi, cos 9 pi, means cos having with odd multiple of pi's, then always its value is minus 1. And suppose if you are taking cos 2 pi, cos 4 pi, 6 pi, 8 pi, means cos function with even multiple of pi's, then always its value is 1. But here it is odd because cos pi is the odd, means multiple of 1 it is, so it is odd, so cos pi value is minus 1. Okay. Now if you observe this f of pi, LHL and RHL, so for this f of pi, we have to equate in one side, LHL or RHL, not both. Okay. And how to decide that? It is very simple. First we have to see what is f of pi value. What is f of pi value here? Pi k plus 1. Okay. The same value where it is present in this LHL and RHL. Okay. Pi k plus 1 value where it is present in LHL or RHL, it is present in LHL. Okay. The same value if it is present in LHL, then that LHL you have to ignore. Which is the value is different from that f of pi, that you have to equate. So this is pi k plus 1. Its different value is what? Minus 1. Okay. There minus 1 is for what? RHL. Therefore this f of pi value will be equate for what? RHL. So that I will write it here. So therefore f of pi is equals to RHL. f of pi is equals to RHL. So f of pi is how much? That is pi k plus 1, which is equals to RHL is how much? Minus 1. Okay. Now simplify this for k. This is minus 1, minus 1. So pi k is equals to minus 2. Okay. or k is equals to minus 2 upon pi. K is equals to minus 2 upon pi. Okay, this is the second example. Now same type of what I have solved it here, this type of I think again 3 or 4 examples are there that to work out as a homework. Okay, already solved in the notes, you just go through it, you will come to know. Okay, one more example I am going to solve it. Actually this is also similar only, but it contains the 3 functions. Okay, I will solve that. But that last example also simple one, not that much difficult. Okay, now whatever I have done in this example, same we have to do it for the next question also, but there we have to do it for 2 continuity points. Okay, so let us take that. F of x is equals to 5 if x is less than equals to 2, ax plus b if 2 is less than x less than 10, and 21 if x is greater than equals to 10 is a continuous function. In this problem we have to find the values of a and b now, not k. We have to find out the values of a and b. Okay, now this function is continuous at 2 continuity points, which are those 2 and 10. So what are done in the second example, same thing you have to do it, but for 2 continuity points, for x is equals to 2 and for x is equals to 10. Okay, so I'll write it here. Given function is continuous at x is equals to 2. First point I will take, x is equals to 2. So the definition is what? LHL is equals to RHL is equals to f of 2. So first we will find LHL. What is LHL? Limit x tends to c minus f of x, which is equals to limit x tends to 2 minus. LHL means what? Less than. So for x is less than 2, function is 5. Now if you observe, inside for the limit, function is constant. So whenever we have the constant function, so that value will be what then? That constant function itself. Next find RHL, that is limit x tends to c plus f of x, which is equals to limit x tends to 2 plus. RHL means what? Greater than. And for here x is greater than 2, function is ax plus b. Ax plus b. Okay, now if you simplify this, what will get it? That is x tends to 2 here. Okay, if I substitute x tends to 2, it becomes 2a plus b. Okay, next we have to find f of 2. F of 2 means what? Equals to 2. So for equals to 2, function is what? 5. So therefore f of 2 value is 5. Actually this I should find earlier, but I have found out later. No problem. So now this f of 2 you have to equate for LHL or RHL. That how to decide I told you. So f of 2 value is 5. Okay. If f of 2 is 5, then in LHL and RHL, where you can find the different value, that you have to equate. So LHL contains 5, so I have to ignore that. But RHL contains the different value, that I have to equate. So therefore, okay, f of 2 is equals to what? RHL. That is equals to what? I'll write 2a plus b is equals to 5. Q this as equation 1. Okay, RHL value is 2a plus b and f of 2 value is 5. That is 2a plus b is equals to 5. This is your first equation. Same part you have to do it for which continuity point now? At x is equals to 10. So if you do it, that is given function is continuous at x is equals to 10. at x is equals to 10, and if you do the same part, okay, you will get the second equation, that is 10a plus b is equals to 21. That is your second equation. See, I have not done this part for this problem, okay, you work out as a homework, okay. So just have taken the equation directly. Now you want the values of a and b, so for that you have to simplify the equation 1 and 2 by using the elimination method, okay. So in this, which variable is same with the coefficient? See here, b, here also b, means I can eliminate b by doing the subtraction. So I will say 1 minus 2, equation 1 minus 2, okay. So otherwise you can use elimination method, okay. 1 minus 2, what is your equation 1? That is 2a plus b is equals to 5 minus second equation is 10a plus b is equals to 21. So whenever you are doing the subtraction of two linear equations, second equation sign changes, plus will become minus, plus will become minus. 2a minus 10a is how much? I think minus 8a, plus b minus b get cancelled. 5 minus 21 is I think minus 16. So again minus minus get cancelled. A is equals to 16 upon 8. So a is equals to 2. A is equals to 2 here. Now this a value you can put it in any one of the equation. In the equation 1 or 2 you will get the value of b. I will say substitute a is equals to 2 in 1 in equation 1. So it is 2 into 2 plus b is equals to 5. So 4 plus 5 is equals to 5. Sorry, 4 plus b is equals to 5. So b is equals to 5 minus 4, or b is equals to 1. B is equals to 1. So these are the values of a and b, okay. So these problems you do it perfectly because these are very important problems. So here I have completed with the continuity part. From the next class we will start with derivative part, okay. Thank you.